Yeah. So let's clearly take the logic. Everybody able to hear me?
Yes.
So okay. Fine. So till now what we have seen is we have started with SGFS and MapReduce, and we started seeing what is scoop, how to import the scoop, and all we've seen. And mostly the thing is we've seen how to store the data and we've seen how to process the data. This is the storing part. This is the processing part. This is the ingestion part. Ingestion of data which is structured from RDBMS and export and import from and to RDBMS. Export and import from R to RDBMS. Okay, this we have seen. And after storing the data or after importing the data, we have to manage the data somewhere. We have to manage. We have to manage it. Like managing, what we say is we need to, if the data is structured, we can impose some structure on it and we can do some sort of SQL things like that. And sometimes we may have to build a warehouse just to store the data. So most of the time what happens is the companies which is recently going on, what they're doing is they're bringing the data for archival purpose. Archival purpose, they are bringing the data to HDFS and then they're just putting it there. Maybe what they are doing is beyond 10 years data they are bringing into Hadoop and storing it there. Like that they were doing. So for that purpose, like not everybody who is working in has knowledge of any programming language or something like that. But everybody, most of them will know the SQL language. SQL competency they must be having. So for that only, we the most popular tool which we are using in Hadoop, I would say, is Hive. Hive is the most popular tool. It is almost used in 80% of the project everywhere. Without Hive, there will not be. There is very less chances of being the any big data project will be there. Why? Because it is very simple only. Let's start. So Hive is nothing but it just equip SQL developers to use the power of big data. And if we want to write one MapReduce program for word count, we have to write entire Java program and then compile it, run it. Then only it will give us a result, right? So that is taking us long development cycle time. The development cycle is more in MapReduce. In MR, development time is more and require programming skills. Correct. So these are the things which MR needs. Compared to that, what Hive required is Hive require SQL SQL skills. All we need to write is SQL skills and then warehousing skills. Those if we can write SQL queries, it will internally what it will do is it will create MR code. Internally it will create the jar and everything. We will just submit the Hive query only. Hive SQL. We call it as HQL. HQL is nothing but it's similar to SQL only. So if we run the HQL queries, internally it will convert it into MapReduce code and then it will run on the cluster. So this is what it will done for processing. For storing and all, we can store it as using the metadata. Like Hive stores the metadata, the data will always reside on the SGFS. Hive is just working like a layer of metadata only. Let's say we have a data, we are putting the data into SGFS. We are having one CSV file here. Okay, this is SGFS, this is one CSV. ru.txt, there is a file is there, and we know it has 5 columns. Just because it's a structured one and it's a CSV file there in the txt format. On top of that, we can just impose the metadata. Hive, what Hive does is Hive is nothing but just a metadata filter. This is Hive. You can query the data via the Hive. You can query and you can do the select star from, you can do many operations through the Hive. But the actual data resides in SDFS only. It does not change. If you want to directly hit the data, that is also fine. You can directly hit the like this one using other shell command also. That is the benefit of Hive. Okay, so let's just try it once. I believe many of you already know about Hive and seeing Hive. If you are starting big data, there should be Hive is very basic. Like everybody should have already come across Hive. So how many of you know Hive already? Have seen or worked or something?
I used Hive to some extent because in my project currently we are using Hive
Okay.
along with the Spark programming.
Spark data frame, right? You use data frame and
Yep,
Hive, right?
yep. Spark data frame and Hive and just for intermediate layer and then data loads to Redshift in Amazon.
Okay. So Salom, you didn't use Hive. Okay, that is good. Any others use Hive?
No, I didn't use to.
Everything okay. Then that's fine. That's very good. G. It's easy to learn from you only. So I'm in the like Linux. I'm just logging into Hive. So as we already saw, Hive is nothing but it's just a metadata structure only. It holds the metadata and then it will import the data into HDFS file if you are while you are running the queries only. Okay. So it's just starting. Okay, that is very good. G. If it is new, it's fine. You can easily learn. So and just now I'm in a Hive CLI mode. Okay, so all I can do is it is very similar to MySQL only. I can do show databases. It has that day we created on database. It is showing us the database. What we'll do is we'll create one database now. Create database test, or we can say September. Okay, I just created one database. Now let's see. So now the database is created. Okay, September database is created. Use September. I'm just going to use this called September. And I just said whatever Hive is nothing but a metadata. Whatever we are doing, it will just use the HDFS, right? So whatever we are doing, it will just create the HDFS behind it. So how it is managing is, let's say just now we created one database, right? We just created a database using here. So what it would have done in a backend is it just creating one folder only. If we create a database, it creates one folder in Hive warehouse called September. That is one folder it will create. Let's say I'm creating one more database, it will create one more folder. Inside I'm creating one table. What it does is it will create internally one more folder for the table. So everything in HDFS is managed based on files and folders. Everything in Hive or Hive is managed only. Managed using files and folders. Okay. Why? Because it is nothing but it is storing everything in HDFS only. That is why it is stored everything in files and folders. Because it's stores the backend is HDFS. HDFS does not support anything but files. So just now we created one database. We'll go and see where the files are available for this. Hadoop fs ls/user/hive. So we have a warehouse. We have the folder called warehouse. Inside warehouse we'll have db. So we have db. If you can see, just now it created 16, 10, 18, 12. It is just created september.db. That is nothing but a folder only. If you see september.db, it's a folder. Currently, there is nothing inside the September.db. As you can see, there is nothing. And I'm accessing SDFS, Hadoop.fs, ls, and then I'm accessing the path, right? So whatever operation we are doing, Hive will create just tables, that like folders and files. That's how it is managing the managing in the behind hoods, that is in SDFS. Till now, everybody is clear?
Yes, sir.
Okay. So now what we will do is,
RG, you created warehouse previously?
No. That's a good question actually. User Hive warehouse is a default one. If we did not give anything, it will get created over there. Databases and everything will get always created over there. If you want to mention specifically for external table, you can change it. That is in our control. But if we did not mention anything, it will get created user Hive warehouse.
Okay. So what is warehouse here? What is warehouse?
It is just a folder. It's just a folder name.
So on top of a Hive, there's a first folder. Then only you can add any DB.
No. That's why, right? It's just a folder structure only. This is how they are defining the Hive. You can change it while installing Hive itself. If you want to change, you can change. In Cloudera, it is maintained like this.
Okay. My question is why it's not straight away. The database is not creating on the Hive. Why it is creating an intermediate?
That is a folder structure, right? They have created a folder structure. That's why. It is a folder structure that is their choice. They may have some other folders or something, right? It is just they decided to have it in a warehouse. So that is a structure.
Okay. Yeah, Aru, can we go and see what is there on the Hive itself?
Hive, yeah, that's why it's nothing. It's just only one. Just now is right?
Okay.
Currently warehouse, but it is in future it might have something, right? So that is warehouse is just for naming convention, right? It is not for something specific. It's for naming convention. So if you use warehouse, okay, that's understandable. Okay, inside the Hive warehouse we have the data, and directly
this is
if you use user
okay,
Hive,
this is
in future something else.
system-defined folder, right?
Yeah, just a folder.
Okay.
It's a default folder for Hive. If you did not mention anything, it will get created over there. Okay. So now let's create one table. I'm just creating one table. Already I'm there in Hive, so I'm just creating the table. So table is created. Let's see what is there inside the DB now. Again, it just created one simple folder inside for our table. We just create table user info, and then we give user ID, first name, last name, DS string, row format delimited. That means row format is nothing but it's just next line /n, and then fields are terminated by comma. That means I'm going to use comma separated file for the table. This is what I mentioned while creating a table. Then it created a table. Yeah.
Yeah, Aru, so the delimiter can be anything, right?
Anything. You can change the delimiter. That's on your our hand only. /n, /t. We can give.
Okay.
Okay. And file format also you can change. File is sequence file, Avro file you can change. Avro, ORC. There are a lot of file format also available. Now it's nothing but it created one folder. That's it. That is user. Currently we don't have any data inside the user info. Nothing. If you once we put the data here, then you will be able to see from the like here. Select star from user info. There is no data available in the currently for the table. So if you want to put the data inside, you can just copy paste to the directory. It will automatically get read. Like that day we have experimented this on Thursday. We just place the data into one folder and then we read from it automatically got read from the Hive table, right? Same you can do here also. But one more way of loading is also there from Hive CLI. That is this command, load data local in path, and then give the file name and then give the target file, target table, override into table user info. We'll do this now. We have the data here, user info. we'll just copy it to desktop, and then let's run this. We need to mention September.user. Anyway, that is already there, but still. So it is loaded. Fine. So let's see, select start from user info. We are able to see the data here, A1, whatever data it is there. And how it is stored in the backend is, it just copy the file from there to here. That's all it does. If you see, user info.txt is there in user info, the folder. So everything is managed tables and files here. Sorry, files and folders here.
Okay, can we see the data now?
Yeah,
Itself.
yeah, back again. So it just copies the data. It did not change anything, store anything, just copies and put the data. As you can see, this is CSV file is there. So you can read it from here also. Got it? Yes. Yes, Anandji, Anbuji, and Ganeshji, Selvanji, and Sivaramji, Vignesh.
Yeah.
Got this one? What's happening? What is the basics of Hive and what is the structure? Everything in Hive is managed using files and folders because it's having HDFS. So is it only HDFS is supported? No, currently S3, Amazon S3 also supported. Most of the projects they are going to cloud. So what they are doing is they are creating Hive in Amazon, configuring there in Amazon. So that is also possible. Currently, this too is possible. But everywhere it is going to use only files and folders only behind it. So that's the thing. Okay, so there could be multiple optimization, everything we can do because of files and folders. We need to slightly differently think in this way. That will come later. Just yeah.
Arjun, I have one question. Like whatever I type here on my machine, it go to next line and I get a greater symbol. That's all.
Where?
I don't get the in the.
Okay, Hive, right?
Mm-hmm.
You should give semicolon at the end.
No, you didn't give right on your commands. Like if you go to the.
No, I gave. Right? See, I gave.
No, not the one. Like on the what do you called?
Here.
On the Hadoop FS minus LS.
Okay. What you do is you should be out of the Hadoop Hive CLI. If you inside, then you will not get. I did not go inside a Hive CLI here, right? I directly gave. Here I'm in a Hive CLI. I'm just in Linux here. If you see, I'm in this path. I'm in Linux. What is that? Linux terminal. I'm not in Hive CLI. If you see here only I have a greater than symbol because I'm in Hive. One more terminal I opened there. I did not go inside anything just because I want to view the file. I'm just simply in the terminal only. Got the difference? Here it is just terminal. Got the difference, G? Hello?
Yeah. Yes. Yeah.
You can quit from the Hive and then you can do that, or you can get one more terminal and do that. Okay, so we just saw what is Hive, how it is structured in a very basic idea. So now I guess you have some idea how Hive works. There are a lot of things to be learned in Hive because that's the mostly used, widely used data warehouse, I would say. And Hive is equipped SQL developers to use the power of data. As you just seen, we've just put select start from and we can fetch the data from the file. Now we're using very simple file, but that can go up to complex ones. That is also can be handled in Hive. Hive is a data warehouse built on top of Hadoop. Yeah, that's a simple thing. It's a data warehouse. Data warehouse means you can have metadata and you can manage the data. What is there in data? It should be there in Hadoop. And Hive stores the data in Hadoop system. That is means HDFS. And one more thing is Hive stores Metastore in one RDBMS database. So what is Metastore? Where all the data is there? Where should it use it? Those things are stored in one RDBMS. MySQL -new root. Okay. So currently one of the limitation is if you want to run Hive in your machine and in your project, you must need one RDBMS database to store Hive's metadata. Hive itself working like creating metadatas and doing all those sort of things, and it is exactly fetching the data from HDFS. But whatever Hive's metadata, that should be stored in RDBMS only. That is called Metastore. Okay, if you can see here, the RDBMS, it can use any RDBMS, like it can be MySQL or Oracle, anything. It can use any RDBMS as a Metastore. So if you can see, I just went into MySQL and then show what is the Metastore for the Hive, whatever we are using. There is a database called Metastore itself. Inside there are a lot of things. What are the DBs we have? What are the everything? All the metadata is stored in RDBMS only. That is a mandatory one. So Hive's metadata is stored in RDBMS. The RDBMS can be anything. It can be Oracle or MySQL or something. Currently, this is only RDBMS supported. But what is they are thinking is they are thinking to replace it with NoSQL database. So that is the thing they are coming up with, but that is not yet. It is in under progress. As you can see here, the DBs. If you can select from the DBs, it will say what all the database is there, what is the metadata of that. Everything is stored there in metadata DB only. As you can see, we created 3 databases. One is default;
Okay.
it will be always there.
Where this metadata will be available? Is it available in the HDFS? Is it stored in the HDFS
No,
or
it is
outside of
there in
HDFS?
RDBMS, outside like outside SDF. This is RDBMS, right? We are seeing in
No, no, no.
MySQL.
RDBMS in the sense, is it stored in the where it is getting stored?
RDBMS stored in Linux.
Oh, okay, that's what I mean to.
Yeah, RDBMS stored in Linux. It has nothing to do with Hadoop. So that is called Metastore. Hive's metadata is stored in RDBMS. Right?
Okay. Can we able to change these informations on the metadata? Like
Yeah, you can
change the owner type and the access.
yeah, you can do updates here. It is possible.
Okay.
You can do.
So what will happen if I change the location here?
It will simply look for the other location there. It will refer from here only. It will show error. If the location is not available, then it will show error.
Okay. So currently now I have a database called scp.db, right? Under warehouse. Okay.
Correct.
So if I want to put into that another library like a warehouse /month/scpdb, so can I replace here itself?
You can replace it here, but you have to create the same folder structure over there, HDFS.
Okay. So whatever I'm going to do the changes here, the same thing has to be done on the Hive itself.
Yeah. Else it will throw error like folder does not exist.
Okay. If I change that directly in the Hive, will it get updated automatically here?
If you change it directly using the alter command, it will get updated.
Okay.
Alter, if you update the folder name over there, it will get updated here automatically.
Okay.
Yeah, that is a metastore, right? Whatever you change, it has to get updated here. That is what metastore means.
And RJ, I have a question on this. I just wanted to understand how the HDFS metadata and the backend metastore, how it interacts, or how they
It is communicated through the services. Like Hive has a service, right? From that JDBC connection, it is getting connected.
Can you repeat again? Because we are not giving any.
Yeah, that is, we are not giving anything. That is given by admin. It is not our job, right? It is the setup. It is the installation part. It is not we are going to connect to RDBMS. It is the installation part itself. It will automatically be there. We are using a Cloudera. Since the setup is already made and created, so we don't have to worry about it.
Actually, Ganesh, did you ever work on Informatica or any ETL tool?
Yes, I know that metadata, and we for every metadata we need to have a base database. So Informatica, I have it in Oracle, even data stage, I have it in DB2 and things like that. So that concept,
Even same thing. Actually, when they are doing Informatica installation, that time they will create the metadata user ID and everything. So that when Informatica installation will create all the table structure and everything. Similar way here also.
Yeah, exactly.
basically the repository on the metadata which we define it in the data in RDBMS.
Yeah.
Yep.
Yes.
Yeah. It is when installing Hive itself, we have to mention these things. That since we are not installing, we don't have to mention. But while installing itself, we need to specify what is our meta store and what is the database. If you give that, then it will work.
Okay. Let me check it in my system because we have Hive and I never realized which meta store that we are using, either Oracle or Amazon one. Because
okay, you can check that. There must be a meta store. You can check that.
And we can just use meta store and we will come to know.
Sorry.
Do we know which when you give the command use meta store? Do we come to know?
No. You have RDBMS. You have RDBMS access in your project.
Yep.
What RDBMS you are using?
I have Oracle.
Oracle. Okay. Then it's a production system, right?
Yeah.
So
I have.
I'm not sure whether you have access to view that database or not. So you can do, if you do source databases, if you can see meta store and go and do select Terraform and see the databases and all. If you can able to see that, then that's a meta store you are using. Else in production, we will not be having access to check, right?
Yeah, I got the point. Yeah.
Only admin will have. So or you can check with the admin, big data admin, whomever is there. Check with them what is the meta store you are using. Then you can easily get to know. Because in our project and all, we will not be able to see. Even I don't know what metastore we are using in our project.
Okay, it's a side note. Sorry, continue with that. I don't want to deviate from the topic.
Okay, so Hive, it is used in very different companies. There are map producers, Amazon, most of the people are using it. So that does that mean Hive is a relational database? No, Hive is not a relational database. It will not do OLTP for us. And it is not a relational database also. We will not be able to do CERD operation directly in Hive. It is not possible. Simply you cannot. Why? Because it stores the data as a files, right? So SDFS is a read only, like write once, read many model. It is not a relational database. Why? SDFS is write once, read many, read more many times model. So in that case, and also one more thing, as you already know, once we put the data into SDFS, we will not be able to edit it, right? Everybody agrees this statement. Data is there in SDFS, we will not be able to edit it. Everybody agree?
Yeah, yes.
So for these things and all, we will not be able to update the record in Hive. We won't be able to update the record in Hive until version 1.2. Until version 1.2, the update is not supported in Hive. If you are using old one 4.2, you will not be able to update. But now, currently, the update functionality is given. Update is given for us, but it is not like widely. You cannot use everywhere. It's not possible. If you give 1 TB and you wanted to update 2 is done, it will take more time. Why? Because currently what it is doing, Hive is a tool. It is deleting and creating the same file again. That's how Hive is managing the update right now in after 1.2 version. So update is not recommended much in Hive. That is the one more thing. So that is why it is not OLTP. It is not a relational database. You cannot do updates, frequent update there. Currently after 1.2 version, the update is available, but it is not for always like always whenever you want to update the data, update. No, it's not possible. It is not recommended. But update is available after version 1.2, Hive 1.2. Okay. Currently version 2 is coming. So there are also a lot of improvements are coming with, along with that. So clearly we will not be able to do OLTP as a Hive as a OLTP. So everybody agrees in this point. Everybody got it. Why we are not able to use Hive as a OLTP? That is the reason. Everybody agrees, or is there any questions or doubts? Yeah, Sivaramanji, can I see? So, and also what Hive is not a language for real-time queries and row-level updates. No, it is not a language for real-time queries. If we give one query, it is going to get converted into HDFS, like map reduce queries. Then only it will be, you will get the results. It is not like you will see the lag time. If you run any job, any queries, currently we did not run any query, right? Let's say, because just we are doing select star from table name. That's why it is fetching the data immediately. It did not run any map reduce program right now. Let's run a program. Let's run a query. Select DS, select star from user info where DS is equal to. Now what I'm doing is I'm giving one query. I'm doing one where condition. Right now it has to run a map reduce to get the results. Sorry, I missed a semicolon. So I'm giving a semicolon. Okay, currently also it is coming as faster. Let's give some another query. Max of average max of TS. So I'm running on aggregated query, like select max GS from user info. For this aggregated query, it is launching a map reduce jobs. Okay, so as you can see, it is a simple query. If you run this in any RDBMS, we would have get the results right now. But here it's not happening. It is creating on map reduce jobs, and then it will run map 0 reduce 0, and then it will give the result.
Okay, here one question, Aruji.
Yeah.
Suppose this is a flat file. Suppose if it is a comma delimiter file and easily we are getting the data.
Yeah.
Suppose if we have some kind of XML or unstructured data, then how it will do? It will do a similar way. It will write a map reducer and return the values.
Exactly, that's how it will return. And if we can use XML, JSON, everything here. There are specific functions for those things. So you can easily fetch. XML means what? It is a semi-structured format. It is not an unstructured format. It is a semi-structured one. Semi-structured is JSON, XML also. So in XML, you have one key and value. It is a, XML. You have a tag like starting tag and ending tag. Correct?
Yes.
Same way, you also have JSON. Also, you have a there is a open brace and curly braces are there. With that, you can have value and key and values. You can easily fetch, right? For that, specific mappers and specific functions are there to manage those file formats. As you already have in Oracle, same is there in Hive also.
Okay.
So with
Thank
that,
you.
you can easily run a function and get the whatever you require, and you can create one more layer of data. That's possible.
Okay.
And one more thing is, if you wanted to manage unstructured data, let's say you don't have any structure on the data, you have to run it on while coming only, you have to impose the structure and all. There you can write your own methods. That is called UDF, which means user defined function. There, this function you can write in Java or Python or Scala, and you can import it to Hive. As you can give a new name for the function. That is also possible. That we'll see in the last, like it's advanced concept, we'll see in the last of the class. That is also possible if you require.
Okay. Yeah. Thanks, Raj.
Yeah, sorry. And currently we are storing the data as text format. So it is directly lying in the data like this. We may, or we can, or we will, for sure we will use different file formats over there. And what is the file format you are using, Ganesh, in your project? Hello? Ganesh?
Yes, Jay. I have to check it out. I never look at the Hive from the file format because I always use the TST only, but sometimes .SQL, .HQL.
No, that is a query you are talking. What I'm telling is, what is the file format? What is the, currently we have CSV, right?
Yes, most
Sorry,
of the time
what file
TST,
format you are using in your project, you can check. Because what is
TST or CSV, because that's what we do that.
oh, you also use TXT or CSV?
Yeah,
Okay, fine.
could be
Then
somewhere, but
how much the data? What is the data size?
data size is close to overall it's for TBs, close to TB.
TBs and you are using text and CSV? Then no, it shouldn't be. Just check the project, because if it is going to TB and all, you will not use CSV or TXT. Why? Because you have a lot of other very good file formats to use and utilize the SDF space. There are something called Avro and Paraquet, and then ORC file format, RC file format. ORC is advanced of RC, and you have sequence file format. There are file formats which will give you very good, what is that, storing also efficiently. It will give, if you want to fetch, it will support CURD operations. Like ORC is a special file format, it will support CURD operation. So for your project, you can try these things. Anyway, we'll see that file formats, but you can try these things. If you are using, I think you should have already using these things because you are handling Teradata, like terabytes of data. Just check these things.
Yep, I'll take a note on that tomorrow. First thing I'll discuss.
File formats. These are the file formats we need to use. If we are going, because this will give us a lot of efficiency on handling the files. Like for example, text file, it is taking 1 TB, means Avro it will reduce, like ORC it will reduce like anything. It gives around 10 times of cost reduction. So those you can check these things. Okay.
Okay.
We will see that is a file formats of storing in Hive or SGFS also. Fine. So it's not a language for real-time queries. As you see, it took time. It has to run MapReduce jobs and it has to give a result. Okay, if that is the case, why do we need Hive? If it is taking this much time and all, then why do we need Hive? Because it is like a ship, like HDFS, those things are created for specific purpose only. As we already see, it is for big data, handling large amount of data, very multiple queries, heavy load queries. Those will be coming to bring into Hive and HDFS. So for that purpose, it will use, like we can compare it with an easy analogy called ship versus bus. Ship versus bus we can compare. So ship, it took a lot of time to start, but the amount of like weightage it is handling and the distance it is going to cover is huge. So ship is built for specific purpose and bus is built for different purpose. So same goes here also. Ship is, we can compare ship and bus, but to some extent only. If that is the same here, if we are going to handle a lot of huge number of data and files and it has to run, then we'll use Hive. Okay. Otherwise, if you want a quick result, you want to result in quick manner, you need to do a lot of queries and all, then you have to go for a bus or RDBMS, other things. Okay, so that is the one thing which we need to remember. And now one more question which may arise is, okay, then if I want to go for HDFS handling large data, do I need to always wait? Is that an obvious question that should come? No, there are some other tools in big data ecosystem that will help us to give the data in a shorter time. That is something called Impala. Some tools are there which will give us, they're having different architecture that cost little bit more. Some kind of in-memory processing that is there. Okay, so that we'll see. But Hive is slow only. It is not fast. Hive is slow, yeah, because it's on map reduce jobs. Okay, so everybody is clear till now about Hive. This is just the starting of Hive, the base. Yeah. Vignesh and Ganesh and Buji and Shivaramanji and Anandji. Yeah. Okay, Vignesh. Thank you. Okay. So let's see one use case where we can use Hive, where it is being already used. There are a lot of things which we can use. One is Facebook. Okay, they were using it for specific purpose. And when we say Facebook, it's a very huge company. As we everybody know, it's a huge company. They are using all the possible technologies, and there are some other technologies which they are only using. So this is one particular use case only. It is not for everything. It's not they are using for entire billions of data. No, they are using this for particular one kind of use case only. For that, what they were using is web server.
RG. Sorry, Anbu wants to repeat the last point from the usage of Hive, before usage of Hive, whatever you were mentioning.
Before usage of this one, right?
Or something you write on the notepad, right? So it has been disconnected in middle. So I just logged in.
Okay. See, there are, if you run any queries in MapReduce, it will take time. It has to run map and reduce, right? So then it will take time to run. But still, when we want to, why people are using Hive? What is the requirement means? It can handle huge amount of data, correct? So that is why we wanted to go to Hive. And if you still want to use Hive, HDFS and Hive, still you want the fast, low latency data, and you wanted to go to quick result for your data, you can go for Impala. There are some other, there's also some other ways to get the data results faster. That is using in memory.
Okay, Impala in the sense, is it outside of Hive or replacement of Hive or something?
Data can be there in Hive. From there, it will fetch. Impala will fetch the data and will store it in memory.
Okay.
It's an in-memory database. It is available only for Cloudera only, but it is not available everywhere. It is Cloudera's product. They created this product, but now anyway, Cloudera and Artenos are combined, so it should be available.
Yeah, thanks, sir.
Yeah, sure. Okay. So here the web server's data will be script. The script means sometimes it will just take the data from there, and then it will be always fed into real-time Hadoop cluster. There is one Hadoop cluster. It will put there. From there, they have a specific Hadoop Hive warehouse. There's a different cluster. They are putting it there, and for that they are using it. They are using MySQL database as a meta store. Okay, so they are using MySQL as a meta store for the same purpose. From Hive data warehouse, they are running a lot of queries. Like they are joining some data, some files, and creating some of the results. And then the final result they are storing into Oracle database. So why they are again going into Oracle means all the process that has been already done, it will give us a clear cut of data, like clear data, which can be used for reporting or used for real-time analytics or something. So that's for reporting purpose. So they are using Oracle for that purpose. So for the just the processing layer, they replaced everything and they put it they bring Hive and Hadoop into the system. So this is one example for Hive, what they can do with the Hive, because they just create HiveQL queries and then they create the results, and then the results can be put into Oracle RAC using Scoop. So it can be always updated in Oracle so that you can view the data over there itself. So this is one use case. The link which you can read more about there is in the PPT itself. You can go and read how it is implemented and all. Main thing what we are trying to tell is it's about processing the structured data. You have to make, if you can make some structure out of something, you can easily write as SQL queries and then it will internally create MapReduce jobs and give us the results. Fine. So what is a Hive architecture? What's happening in the behind? So the same thing only. We will access it using web UI, Hive command line, or HD Insight. HD Insight is just IBM's thing, and we can use it to access Hive. So whenever we run a Hive process, Hive queries, it will change into HiveQL process engine. It will contact the metastore and get the data, and then it will execute it. Once the execution engine, what it will do is it will convert the whatever the process we have run, it will convert into MapReduce, and that will run on HDFS or HBase. That day we have seen we store the data in HBase and we created the Hive table and accessed it. Okay, that is also possible. To access it, we need something called H catalog. That we didn't see that yet, but just we can keep in mind. Once we go into HBase, then we will get it. So how the things are getting executed in Hive? So once a driver runs it, then it will go into execution engine. Then it will exactly run the same way. How job tracker, task tracker, everything runs, it will run same like that only. And here compiler, like driver will go into compiler. Compiler will get in touch with metastore and then get the required metadata, where the data is stored, what is the folder structure, what is the where it is stored, everything it will get. From there it will go into Hadoop and then MapReduce jobs will get run. Hive is responsible for creating MapReduce jobs for any query that is given. Okay, then it will create a MapReduce job that will run in a specific way. Then it will complete map and then reduce as usual. Fine. There are some concepts which is there in Hive. So whatever the things we are seeing, that is being managed in files and folders. Just now we have already we have seen databases. If we create databases, what is happening is it is creating a folder. It is creating one folder over here, correct? If we create one database, that is creating one folder. Folder that is a database. This is a Hive database. DB, right? This is DB, and inside DB we have table. I'll just write one properly. This is, let's say this is SDF. This is Hive. HDFS. In HDFS, we will have databases. Inside databases, we will have a lot of tables. This is one table. Table 1. Table 2. Table 2. Inside, we will have the files. If inside, we will have the file user info.txt. Correct? This is a one table. Okay. Right. Okay, so this is how it is getting stored. We can have databases and we'll have altogether different databases also. We can create one more database like this. That will get created one more different folders. Inside folders, you'll have tables that's also come in as a folder. Inside also you can have one more folder. That's how you can keep on create. You can keep on create and going. Okay. So databases, there is nothing else. It's just a folder that's getting created. And tables, we have two kinds of tables. One is managed table, another one is external table. Okay. So you create a database, that is fine. In tables, if you see, there are two kinds of tables. One is managed, another one is external. So what is managed and what is external? We already created one table, that is we call as managed table. So in managed table, what we have done is we did not create any location here, right? We did not give any location here, and it is created in a default location. And if we delete the table, let's delete the table. Currently, the data is here in the folder, right? The data is here in the folder. What we are doing is we are going to drop the table. Drop table user info. So the table is dropped. Sorry. So the table is dropped. Let's see the behind what's happening to the file. So the data is also deleted. So data is also deleted. If we drop the table, if we drop the managed table, the corresponding data that will also get deleted from HDFS. That is called managed table. Okay. So that is the managed table. And let's do the same using external table. Let's create one external table. External table and managed table, what is the differences? I'm just giving the like syntax here as external. And then I'm giving one location. I'm just giving store it here. That's what I'm going to give. Other things are same. Okay. So all I did is I created one external table now. Previously I had one managed table. Show table. Anyway, I dropped the table. So we have only one table right now. That is user info ext. Okay. So let me do the select. Select start from user info ext. There is no data available. Okay, let's load the data. We can do same query for external table also. Local data input user info.txt, that is fine. User info underscore ext. Okay. So I am running the same query to load the data. So data is loaded. Loading data into Xstring. Let's see whether the data is there in this location or not. Hadoop fs ls. So data is available here. That is fine. Okay. So data is available here. Let's do the select start from the table whether the data is available here. Okay, the data is available in the table also. Fine. Now let's delete the external table. Drop table user info ext. Now the table is dropped. There is no table, but the data here will not get dropped. As you can see, the data is still there. We loaded it using Hive, using external table, but if we drop the table, the data will not get deleted from the HDFS. That is the main difference between external and internal. Okay, I'll just write it here. Managed versus external table. You can say managed table or internal table also sometimes people tell. Internal or managed, both the same only. So if we drop the table. Deleted in managed table, but data will not get deleted in table. Only metadata will get deleted. Fine. You got it? The difference between managed or internal table versus external table. Yeah, Anandji, Anbuji, and Ganeshji, Salumji, and Sharamanji, and Vignesh.
So if metadata is deleted, then what's the point of having a data?
Exactly. The data, what is the point of having the data is, your data is safe. Even if you accidentally delete the table, your data is safe. You are not losing the data. That is the main purpose of using external table. And in production systems, 90% we use external table. We will not use internal table or managed table. We always use external table for safety only. If you accidentally delete the table, your data is still available. You can create the table again. You can just create a metadata. That's fine.
It's an external table and the managed table. It's it's a terminology which just while creating a table we use that.
Yeah. Correct.
It's not like external table means we are getting a table from the external sources.
No, it's not like that. It is just a terminology. This is just a functionality. This is the difference. If you delete the managed table, data is going to get deleted. If you delete external table, data will not get deleted. That is it.
So when you say create table, external table, or create external table, create managed table.
Correct. No, managed table, you don't have to give anything. Okay. If you did not give external, it becomes managed table automatically.
Okay. So once in a external table, in a external table, the metadata is deleted. How do you get back? How do you get the metadata to get the table work back again?
Once we delete the external table.
Yeah. Once
again
we
need to run the same. Sorry.
Oh yeah. Okay. That's so again we need to run the create command.
Correct. Yeah.
So then this will go and sit in the metadata.
Yeah. Correct. So in production or whatever the live system, we always use external table only. And also, external table is kind of, you can easily point it to one location and you can keep on adding the folders. There is not much difference between external and internal other than this. So always recommend external table only. Internal table where we will use. If we are using some layered approach, you are going to, let's say you have multiple layer of working. Like in our project and all, we have layers of working. Here you have to join two tables. One intermediate results are going to be there. Intermediate results. And then with this results of table, you are going to join with some other table to get the results. Layer 2, what you are going to do is previous results join some other tables. It is going to create me the final results. So this is going to be the short-lived table. This I will create a managed table. Because anyway I'm going to delete the data altogether once it is done. So I'll create managed table for that purpose because it just helps me. I don't have to delete manually data. I just delete the table, it deletes it. Understood?
So will there be any difference in memory, something like that, if it is managed or external table?
No, there is not really much difference between managed and external other than this. It works the same.
Okay. So another question, Aru, suppose if we are creating with external table, but we are in a situation where the particular data in STFs we are not required. Okay. So is there any possibility to delete it completely if it is external table?
Then yeah, you can go to you can delete this, right? You can delete using HDFS-RM. Manually, you can write a shell script and delete. This command will delete it.
Okay. Yeah.
So RG, the metadata means it's basically your just a table structure, raw table structure.
Correct. Metadata is just a table structure from not data, only table structure. That is metadata.
So yeah, if you are copying from the RDMS, then you copy the same table structure and just
correct. Yeah. So that is tables and partitions. We have something called as partition. Now, what does partitions means? Let's say we have lot of information, like we have 1 year of data. 1 year of data we have, and each month we have like 10 GB of data. Each month we have 10 GB of data we have, and 1 year, 12 months we have all the data. If we put every data into only one folder, if we put everything in one folder, it's going to create huge, it will create, everything will be in one folder. Then if you want to run analysis for only July month, let's say July month only you want to analyze something, then in that case what happens is the control has to go and check every data, like entire data, to get only July month. Okay. In those cases, what we can do is we can partition the table. We can partition the table based on months. What it does is it will create the folders inside the tables, and then it will store the data inside the partitions. So we can create partitions inside the table. This is partitions, and we can store partition like January month data. We can store it here. You can store it here, and February you can store here. The March you can store here. The April you can store here. So in this case, it will hit only those folder and will fetch only the record. It will be much faster. So that is what we are calling it as a partition. If we give partition also, it will get created in the scene as a folder only. Okay. So let's create something.
It's a folder or it's a separate TXT file?
Folder. Partition is nothing but a folders.
Okay.
So let's create one table with a partition. Create external table. So here what I'm doing is I have 4 columns, same data, but I'm giving only 3 columns inside and giving the last column in the partition by column. Okay. So again I'm creating one thing. Create external table, user info part. I'm giving 3 columns inside and I'm giving the last column as a partition column. Always we can give only last column as a partition column. Then again I'm loading the data. So if you want to load the data into partition column, you need to load it from another data only. That is the easiest way. For that we require the previous table. So I'm just recreating the same. Okay, I just recreated the previous data because from there we are going to insert into partition table. From user info, I'm getting the data and then getting this data and inserting into here. So here,
one second, I'm seeing the commands. One second.
Yeah. Okay, few minutes, I'll be back. Yeah. So here, like other than the previous query, here we did something else. What we did is we are inserting the data from one table to another table and creating a partition. Okay, so this is a query, like from this table insert override into the partition table, and we are giving the which partition it has to be written, and then we are giving the query. Like from in the query itself, what we are doing is we are selecting only the DS data which is a 12 and 3. So which means only this data will get from here, and then that will get into partition and that will be inserted over here. This is called static partition. This we will do whenever we know daily we'll have, let's say daily we are receiving one file, and we must know like this is the data we'll be getting, and this we need to insert. Okay, in that case we will use the static partition. Okay, let's just see what's happened in the behind hooks. User info part. The table focuses. Part. User info part. So the data is not there, but the partition column is there. So inside will go again. Here we have a data. So if you want to see the data, only this data is there. Fine. It is there inside this partition folder inside. Got it? This is static partition. Yes, Ji? Ganeshji, Anandji, and Anbuji.
No, I didn't get it actually.
Yeah.
Can you? Yeah.
But RJ, for info part, for other three fields, where that stored into only the partition stored.
Yeah, that is this is those things, right? Inside the data it is there. This is the other three fields, right? The files it is stored. Last field is stored as a folder. In the three files are there as a files inside file. If this is the file, this is files. This is the content inside the file. A1 John, Kate is there, Vasagam is there, Paradhi is there, right? So it is there as a stored inside as a file. Other three things are stored as a file. Still there it is a directory. Inside there is one more file which is called 000 because it is created out of MapReduce. There it is stored. Understood, Ji? That partition column is getting created as a folder. Other things were there inside the file. Yeah.
So you took the big file and you took the only this piece alone from that file and you put it separately. Is that?
Sorry, I created.
No, from the original file, you took this four data and put it in a partition that 4 data
Correct.
and put it separately.
Same, correct. You're right. I did the same. But I did it using one query, Hive QL query. This is that exact query. From this table, I'm inserting into this table using this condition. This is my partition column. This is the exact query which I used for that purpose. From this table, you take all the data and run this query, which will take only 12/3/2016, and I'm giving the partition column as the same. That will get inserted. From the previous data, it will get only those data. In those data, it will get inside the partition will create.
So on the original table, we do have a column name called DS.
Yeah, exactly. We have.
So then why you're writing a select command after this? Partition is done.
Then how do you get only the 12th data? Because in the 12th partition, you want only the data of 12 to be present, right? I can remove both here and there. That is called dynamic partition. I can remove the condition here and remove the condition here also. But that is called dynamic partition. Dynamically, the partition will get inserted. That you can see in the next line. Here, if you see, I removed the same in both. Like here also I removed, here also I removed. This will create how much data is there in the partition column, that much folder it will create. All the data will go into respective folders. But I have to put here dynamic mode non-restrict. This is the settings which I have to change. Hive execute dynamic partition mode non-restrict, then it will get created. I'll just do that. It is set. Now we'll run this. Without the condition I'm running. Now you can see it created 3 MapReduce jobs because it has that much data. Got a difference between this and this?
Yeah, this one you don't have a condition, so it's like it's a duplicate. It's
no, it's not duplicate. It will not. It's not duplicate. Like it will go into respective folders. 12 will go into 12. 13 will go into 13 folder. 14 will go into 14. That will happen. It's not duplicate.
Okay. So it's segregated by day. Then.
Yeah, it is partition by date. Once it created, we can see all the partitions getting created in the target folder. So only difference, this is dynamic, this is static partition. We are explicitly mentioning the partition folder in the step 4. In the step 5, we are not mentioning anything. We are telling whatever the data comes, you itself create the partition on your own. If the new data comes, you create new partition and insert. How much data is there, that much partition you create from this table. That's what we are telling in this query. In this table we are manually getting only the 12th date's data, and then we are manually specifying the data's date, that partition's date. That is the difference here and here. This is dynamic, that is not dynamic.
So can you see this data in the HDFS?
Yeah, we can see. As you can see, it's completed. There are 3 partitions getting created. Now 3 folders created, right?
That means that has only 3-day data.
Yeah, correct. Exactly. Inside each thing, whatever the data is there, that will be stored inside. 12 is there. $14 is there. Sorry, 14 is not there. Only 11, 12, 13. If you give one more data in that time, then it will get created for that also. So that is all the partition is about. It is just getting the it's just creating folders and then inside putting the files over there.
So for the dynamic one, basically the map reducer will look for the key and values, and it creates the file based on the value.
Correct. Yes.
It is so smart that it knows what key values are coming up for that date field and then creating it by own.
Yeah, it will create. Correct.
Aruji, if we delete this partition table, the data will also delete?
Because we created external table, right? So data will be there. We created as external table.
Okay.
So data will be there only.
But if it's a managed table, then it will delete.
If it is a managed table, the data will go.
Even though the partition, if we delete
Yeah,
a partition,
everything will be gone.
But before that, can we just take a look at the data? What we have it in the partition?
Okay. Inside here, right?
Yeah.
Yeah, this is only 2 record is there for this. So that's it. Some other character, I don't know why it came. It is a separator. I think it is. We are not able to see it using CLI. That is why it is showing like this. But the data only 2 record is there for this 13. We'll see.
can you open a VA editor?
So here 13, 2 data is there. So 2 data is here also, right? 13. 13 is, this is the table. From here, 2 data is there. So this is 823 Sachin Tendulkar. Sachin Tendulkar is there. And then Arumugam is there.
But RJ, I have a question over here. So partition, I got it. We are just segregating based on the need. But while retrieving it or selecting, we are not looking at the partition. No, we just gave the table name. But but internally it fetches from the partition table and bring it to us.
Yeah, we did not fetch that from there, right? But we will see. I'm getting the data from another table, external table. Start from user. Yeah, it will, if you did not specify anything, it will fetch entire data from all the partition itself. As you can see here, it's started now 11, 12, 13. Same data, it is from the partition.
Right. Okay. Info X, there is a whole overall table, and if you give info partition, sorry, can you just repeat the differences? How is it?
There is no difference. When you are querying, you will not find any difference. It is just get the data from the partitions,
Okay, I can see the time taken is a little less when compared to the original one.
What is less, G?
The time taken, because there it is saying
time taken is that is fine, but it
because
is not much impact. Yeah, the time taken is less, but we cannot exactly see using this thing. But yes, if you go for more data, you will be able to see a lot of time difference. Here it is not much.
Okay.
Here it's almost same only because it takes microseconds. Time taken is 6:1 here, 1:2. Yeah, there is a change, but it is not much. If you go into more data, then if you're hitting only 1 month and all, then you will gain a lot of data. Time taken will be less.
But one thing is that we will be adding additional files to the HDFS, correct? So the storage will be a thing.
Arju, can you open the partition which you had with the condition, that table?
Yeah, that is a partition here. The condition is this. Only one table we created everything. We inserted everything to one.
No, the first with the one table we had with the condition, right? Remember 12 only.
Which one is this one, right?
That table should have only the 12th data, right? So no, the other one, the one in the top, yeah.
No, both the same only. We are doing the where condition here, right? That is how it is having 12th guy only.
Can you run that and can just run that and see that it has only one data for 12th data only?
No, it has all that. See, this is the same table. If you see, it's the same table, right? I am filtering it out using the where condition here.
Right, but you're putting in a user underscore info part.
Yeah.
Can we create that as separate?
No, if you see here also same, it is already overwritten.
Arun, Aru, the thing is, can we retrieve only one row
Yeah.
from the particular partition?
One row or one data? DS.
One condition, that's fine. Use the one condition.
One row.
Oh, one. No, not one row. One partition's data.
Yeah.
Correct?
Yeah, that's true.
That is possible only. This.
Say if that has only one data, then it will come only one row. If that has more than one row, then you have.
Yeah. Where DS equal to 16. Yeah.
Yeah, this is
Same we can get. It is faster.
right, but what we are asking, like partition it with the one row, just and
You want to
see that.
partition one row.
Yeah, I mean that one data set. Yeah, the same one. But can you change the different table name, user underscore info part? Instead of that, can you just put a part one or something like that and run the same query? No, the top one, the one up one.
Okay.
Yeah, one. Yeah, can you run that query and see?
No, this has 3 records. It already told us 3 records. Again, it will go to 3, right? You want to go to one record means you have to change it.
No, 3 also fine. I didn't. Yeah.
Okay, you want to see whether only one data set is fine or not, right?
Exactly. Yeah.
Okay.
So because right now all I have are 8 rows, so 8 data is fine.
That's fine. When I got it. Let me.
I hope you overwrite it again with part one.
You put a category, cat. That's the reason instead of ls.
Okay. Only one folder is created, right? Is that you asked G?
I mean, see, yeah, the data set, one data set is open, right? Open the cat that file and see what it has. So we want to, I want to see only that. It's just not 8 records. We should not have 8 records now.
Yeah, it will not have 8 records. 4 records.
So now, so basically, it is not saved in the user underscore info underscore part, but it's saved on the data set.
Yeah.
Why again you give the condition like DS equal to this one? Because
we are manually controlling here we are manually controlling it, right?
Okay.
If we are manually giving the static partition, that is why you are telling, okay, all the data should go into this partition. Then you have to only fetch those data, right? If you give 11th data here also, it will go, but it's wrong. It's wrong in terms of user perspective. I can give like this 11, it will still work, but it's a wrong data, right? The data is wrong. You understand, right? That's why we are mentioning it at 12. This both should be same in order for our user, like it is for our purpose. We can give 11, it will still work. It will what it does is whatever we are telling it will do. It will fetch the 11th data and put into this partition which is created for 12th, because it doesn't know, Hive doesn't know. We are controlling it. That is the reason. That's why we need to put 12. If we don't want to give anything, we don't have to give anything. That is a dynamic partition. We can give it DS.
So no, the data is saved in a DS instead of user underscore info part 1. That
data stored in info part only. Inside DS, correct. Info part, that's what we are telling it here, right?
Right.
The partition will get created, one more folder. Inside that only the data will be stored.
Yeah, it's not directly saved in the user underscore info part.
Yeah, that's what we have seen from the beginning, right? Like partition is nothing but a folder getting created inside.
Okay.
How many partitions you have, that many folders will get created. Inside those corresponding data will be there.
Right. Okay. So the one partition is equal to one map reducer. Is that the way? Or like
yeah, correct. One partition will get will be needed for one reducer. It's not one map. Map can be more, but reducer is one. If you have 5 partition, 5 reducer it's can be. Our reducer will morely come into the picture of bucketing next to process.
But RJ, before going to that, I have one question with respect to partition. Okay, today we got the 12th and we loaded, and tomorrow we are getting some more data for 12th. So in that case, say for example, still it will be appending to the same partition, or it will create.
Yeah, it will append to the same partition only.
Or it will override the existing partition.
Here we are giving override, so it will override. You have to give append for here. Then it will get appended. Insert append, instead of override, you have to give insert append.
Okay.
Okay. Yeah, I think we are running a little bit of more time. Okay, we'll see bucketing tomorrow. We'll start with bucketing from tomorrow onwards. So yeah, with this we'll wrap our today's session. You can like this folders, everything is there in our folder, folder. You can check those things like the data set and the data set and everything is there in our assignments inside Hive. Go into user info, that is the data, and then Hive steps, that is the particular thing we are using. So let me delete this, whichever is not necessary. And beginner, there is one more guide is there. It's a simple use case, like how to do everything. That is also you can go. How to create DB, everything is there. Step by step is there. That also you can go. There are some more documents available, but only all you can do is Hive steps you can saw. You can go through, and then user info is a table. These two, whatever we are working, these two only we are working. Other things are just for your test and purpose. Hive lab, there is something, there are a lot of works where they're in Hive lab also. So you can go through those things. Okay. So yeah. These questions we will see in HBase time. This is HBase queries. We'll answer this in HBase session. Okay. So any other questions?
Good, RJ. Thank you.
Okay, guys. Then yeah, I hope today's class is useful and interesting. We'll see you tomorrow class. Thank you. Thanks everyone for attending today's session.